All right, we are going to take a look. Let's see what you came up with. I know you're maybe not done, but I want to have an opportunity to go over some things and kind of come up with some methods. I saw a bunch of different methods. Let's talk first about the square. What we're looking at is two different methods to find the area of the square. And a lot of people did the same thing, okay, which is okay. That's perfectly fine. You actually could find the area of a square directly, which, by the way, how do you find the area of a square? Yeah, it's just base times height. So if I can find the base and the height, which are the same, then you can go through and get the answer. That's what a lot of people did. Okay. So a couple of things that you know about a square. You know that the diagonals bisect each other, so therefore those two parts are equal. You also know that they are perpendicular. Okay, so you know that these are all 90 degree. They're all right triangles. You also know, because of the 90 degree angles of a square, that the diagonals are the same length. So all four of these parts are actually the same. So you've got 6, 6, 6, and 6 for all four of those. You could go even further. One of the other parts we talked about last chapter was that the 90 degree angles of a square, the diagonals bisect that as well. So you also know that these are 45 degree angles, okay? Because that's one of the properties. So you actually have a 45, 45, 90 triangle. So if, and like I said, a lot of people that I was looking at, the number one method that I saw people use for a square was they saw the fact that these two parts were 6 and you got a right triangle. A lot of people use Pythagorean theorem to find that side length. And therefore all the side lengths, okay? Which ultimately you should get, what is it? What is it?
8.49.
8.49 approximately. Okay. So if you use Pythagorean theorem to find a side length, you end up again and again. You know it's a square. You know all of the sides are 8.49. You can go through and multiply those. Somebody else did a different one. Bonnie was doing a different one, which was good. She went through and recognizes a 45, 45, 90, and therefore used relationships. If this is 6 and that's 6, then this is 6 squared to 2. Using your 45, 45, 90 shortcut, okay? And 6 squared to 2 times 6 squared to 2, which is 8.49. She went through and did it that way, which is also very good. Ultimately, you should get an answer for this area of 72. It should come out, it may not come out exactly if you rounded the decimal, but it should come out to 72, I believe. 0.25. Is that what it is? If you use the rounded decimal, is it 0.25? Let me think real quickly. Yeah, it should come out. If you use the exact answers, you should get 72 square units exactly. Okay, if you use rounded answers, it might be a little bit different than that. Anybody do it differently? What was option number 2? Most people went through and found the actual area of a square directly. What else could I have done? Albert?
I found the area of like one triangle and then I multiplied that by 4.
Okay. Another option, you could just focus on one triangle, find the area of one triangle, and actually it's a lot easier doing it that way. Even though this isn't hopefully too bad, if you take a look at a triangle, for example, I'm going to look at the bottom one right here. You know that you have a right triangle right there, and you already know that the base and the height are both 6. So if I find the area of that triangle, I don't even have to find any, I don't even need the 8.49. You've got perpendicular lines, so 6 and 6 are your base and your height. 6 times 6 is 36, divided by 2 means the area of this triangle right here is 18. And I've got 4 equal triangles. 18 times 4, 72. So you could have done it that way. I don't know if anybody did it this way, but I've seen it this way in past years. You could have cut this into 2 triangles. I think, Gary, you were talking about that. You could have cut this rather than into 4 triangles. Maybe look at it as 2 triangles and said, let's take a look at this half, try to find the area of that triangle, and then just double it rather than multiplying by 4. That's perfectly fine. Okay, you should get the same answer of 72. And there's other ways as well. But what I wanted you to recognize is, in this case, we could find it directly with the 8.49s, or multiple different ways you could break that into triangles, break that into other shapes, and find it that way. Okay? How about on part B here? Now The regular hexagon.
Not an infinite, that's
The regular hexagon. I'm going to come to you in a little bit here, Jordan, but not yet. I'm not ready for you yet. Ayana, what were you trying to do? And I don't know if you got there or not, but what were you trying to do?
I was trying to do like two trapezoids, but
Okay? So, you could, if you notice in a regular hexagon, if you just kind of split it, you basically have two trapezoids, one on top, one on bottom. And you know, since this is a regular hexagon, that all of these sides are 8. And you do have a way to find the area of a trapezoid. You need both bases. You also then would need to go through and find, a height. So you can do it, but there's a lot of work here. Okay? So it is an option. Cody, what do you got?
I did end up doing it that way, but I went back and did it a different way.
Okay, what's the other way?
So I made 6 isosceles triangles.
Okay? And hold that thought. And that's where I was going to come to Jordan too, because he did that same thing. So another option is, we could cut this into multiple ways. Here's something, by the way, and I want to see if anybody did this. It's actually a really creative way of doing this. I've seen this in the past. Some people went through and have done this before. What 3 shapes do I have? Got 3 rhombi. So I've seen people try to cut it into 3 rhombi in general, okay? And try to do it that way. Again, it's pretty messy, okay? It's not the easiest thing by any means. And again, remember what we're trying to do ultimately is I want to come up with a method that doesn't just work for a regular hexagon or a square, but will always work, okay? So I'm going to kind of go off of what Cody said, and then I'm going to come to Jordan. So Jordan, what did you do?
I split the hexagon into 6 equal triangles.
So let me ask you this question, not you, but in general. If this was an octagon, could you do that? Could you split it into 8 equal triangles? If this was a decagon, could I do that? Did I do that in a square? Okay, so the point I'm trying to get at is, we talked about possibly splitting this into 2 trapezoids. Well, I can't take a square and split it into 2 trapezoids. That's not going to work. I can't take an octagon and split it into 2 trapezoids necessarily. That isn't going to work. A heptagon, a pentagon, things like that. It makes it a little bit more difficult. It doesn't always work, and that's what I'm trying to find, is something that will always work. Okay, so we did that. So Jordan, I think, Cody, you already mentioned it, but I'm going to come to you, Jordan. What kind of triangles do I have?
Isosceles.
Yeah, the idea is, if you take a look, I know that if this is the center of this shape, if I draw in a line from there to this vertex, and then I draw in a line to this vertex, I know that distance has to be the same. Okay, because you're just going to a vertex regardless of which one. So you know that this triangle has to at least be isosceles. There are some shapes that end up being equilateral, okay? But it's at least isosceles. So I know for sure that this equals that. So here's the question then. Now what? What did you do next, Jordan?
I thought they were both 8, so I turned it into a right triangle. I split it into 2.
So you split this right here next?
Yeah.
Okay. Were you able to find any angle measures or anything?
I did find out that they have 90 degrees, but that's about it.
Okay, so we're running into a little bit of a problem, so we got to figure that part out. What do we got, Aubrey? What do you think?
I did the same thing, but instead I found the angles right away.
Okay, so let me back up for a second. Oops, that didn't go well. Okay.
And I found each angle was 1/20th, and then if you split it, it was 60 for each triangle.
All right. So you found these angles,
Yeah.
the angles of a hexagon. So that's what we've been working on, right? How do you find the interior angles of a regular shape? That's exactly what we've been talking about. So if I wanted to find what each one of those are, remember, we find the sum of all the interior angles and then divide it equally amongst, in this case, 6 angles. Okay, and so what Aubrey had said was, she said each one of these was 120 degrees. So then when I draw those lines in, that means that this is 60 and this is 60. Which means, by the way, what's the top angle then? It's also 60. Which it means, by the way, what kind of triangle is this then? So I said it's at least isosceles. This is the one shape. A hexagon is the one shape where when you split this into triangles, it actually turns out that those are equilateral triangles. Which, nicely now, if that's 8, that means this is 8, that means this is 8. Now I know the side lengths of those triangles. One other quick thing, by the way, I'm going to give you a different way of finding the angle, just another way. If I put all these triangles back in, what's another way I could have figured out that the angles were 60? Any ideas? I'll give you a hint. I would have started with this one if I did it that way. Cody?
You can find the exterior angle?
You could find the exterior angle. I'm going to go a different route. Here?
360 divided by number
Yeah. Take a look at all these angles. If you put these all together right around the center, those are called central angles because they're around the center of the shape. All 6 of those angles have to add up to 360. They go all the way around. 360 divided by 6 gives you a 60-degree angle. And then if you know that this triangle is isosceles, you know that these two have to be equal. So 180 total minus the 60 you already have, and then you split it between those two triangles. Okay? So just another method. It doesn't matter whether you find the interior angles and cut them in half, or whether you find the central angles and use it that way. And here's kind of my final question that we're going to kind of end on at this point because of the fact that we're running a little bit short. But does this look familiar at all? This problem? You have basically an isosceles triangle that you're going to go through and try to find the area of. See, there's a reason why I went through part B in the homework. Because now, if I wanted to find the area of that triangle, there's a method right there, okay, which is what we will kind of pick up with on Tuesday. Here's what I want you to be doing, though. Here's what I want you to work on. So a couple things, if you still have your practice to learn now. 815, there's a couple problems you can ignore. You can skip problems 64 and 65. Reminder, last week's Delta Math assignment, the G26 assignment, is due by tomorrow. So if you still haven't done that, make sure you get that done first. And there is the assignment that is due by next Friday. Okay? Other than that, have a good weekend. Unless I'll see you tomorrow.